So hi everyone, and welcome to this webinar on Oasys REPORTER pedestrian protection templates. Thank you both to those who are joining in person today and those that may be watching the webinar on YouTube later. An introduction to myself, my name is Katie, I'm an engineer at ARP and I've been using LS-DYNA and the Oasys software suite on a number of projects in different industries, including structural and seismic projects, but also on automotive projects and more specifically for pedestrian protection analyses. Firstly, a bit of housekeeping for the webinar. If you're joining live, please try and keep yourself muted during the webinar. If you have a question, you should be able to type it in the chat and I'll try and answer all of those at the end. And the webinar will last less than half an hour. As you may have guessed, the focus of this webinar will be using templates provided with Oasys REPORTER to automatically post-process head and leg impact analyses. For those that aren't familiar with it, Oasys REPORTER is part of the Oasys software suite and offers automatic report generation. But just to go back to the overall pedestrian workflow again, so starting from an input model, this webinar is actually the second webinar in a series of 3. So do check out the webinar given by my colleague Harry, which goes through the pedestrian markup and model build tools within Oasys Primer, which cover these 2 steps in the workflow. The LS-DYNA step in the workflow is just running the analyses, which can be submitted through the Oasys shell. And as I've said, this webinar will focus on this part of the workflow, the reported templates available for post-processing head and leg impact analyses. And the final webinar in this series of three, which will happen in a couple of weeks' time, we'll look at the HIC area calculator and pedestrian run builder tools, which are useful for interrogating head impact results and setting up studies. So let's say I've just finished this stage of the workflow and I've run a full suite of head impacts. And we can see them in this folder here. So I've got my adult head impact analyses, cyclist and child head impact analyses. And if I go into one of these, I'll see I've got all the results. And now what I want to do is extract the head injuries for each impact point I've analysed and calculate the head impact performance against a certain regulation. That might be Euro ENCAP, China ENCAP, or the GTR legal regulation. And I'm going to talk through how we do that in Reporter. So if I just open up a new Reporter session, and when you do that, it will load. Give it a minute. It will load this page. And so I could actually create my own template starting from one of these standard templates which are provided. But we also have a library of templates which are provided with Reporter. One of the categories of those templates is the automotive templates. So I've just gone to the automotive tab at the top here, and we can see that we offer templates for several different regulations for both occupant protection and pedestrian protection. Today we'll just filter to look only at the pedestrian protection templates, and we've got templates for both leg and head impacts. And we'll start in this webinar looking at the Euro and ENCAP head impact template. I'm going to choose the latest version, which includes the cyclist head impact points on the windscreen, and then I press OK to start the template. The first thing it asks me is which list files am I providing, and this is these list files are generated by the Oasys Primer model build tool. The other option I have to choose on this panel is whether or not I want to skip impact points which haven't reached normal termination. So Reporter will check the OTF or D3 HSP file in the run directory for each analysis and ignore any runs which don't have normal termination if I tick this box. I'm going to post-process adult, child, and cyclist points. We'll hit OK. And the first thing it wants me to do is select the list file generated by Primer's model build for the adult head impacts. So I say OK, and it will take me to a File Explorer window where I can choose that list file. Now, One thing to note as well is that even if you haven't used the Oasys Primer model build process and you've maybe built your models in a different way, the format of the list file is actually very simple. So if I just open that up in a text editor, we can have a look at the format of that file. And it's actually just the path to each input keyword, the name of the point, the x coordinate, the y coordinate, the impact angle, and the z coordinate. So you could generate your own list file to feed into the reporter template if you haven't used the model build tool and so you don't have one already. If we go back to reporter and I choose the adult points, it's telling me that in order for the template to run, it needs some information about the inputs, such as the node IDs and the units of the model, so that it can extract the head acceleration time histories. That adult list file, which I selected, already contained the required information, and it's asking me just if I want to use that data. So I'm going to say yes. Now it's asking me to select the list file for the child head impacts, and I know that my child head impact list file doesn't already contain the required information. So if I choose that one, it now has a different message saying your list file does not contain the necessary information. And what will happen now is Reporter will launch Primer and load up the model and allow me to input the information that the template needs to post-process the results. So that's what it's doing now, loading up Primer. And it brings up this little GUI here. And the first thing I need to do is select which impactor model I'm using. So we've got either the Arab Selborne head impactor or the LST head impactor. I then need to select the node in the head form, which I want to read the acceleration time history from. Actually, in the case of this impactor model, there is only one database history node defined. So I can just select that for both the X, Y, and Z accelerations. Once I'm done, I need to press Save as List, which will save this information for next time and let me continue working through the template. So I've already gone through this process for the adult list file, which is why we didn't end up in Primer when we chose that one. But this is the process we would have to follow if we've not already set it up. And by pressing Save as List, it will save the information for next time we want to use the template. Final step then is to choose the list file for the cyclist head impacts. So we just select that one. And that one already contains the necessary information. So we say that we want to use that data. And then the final thing we need to do is tell Reporter where we want it to output any images and curve files and results to. So if we say, OK, we can make a new folder called analysis results, for example. Now we finished with the inputs for the template and the template started running. So Reporter has launched THIS, which is our XY data plotting software. And THIS is going to start reading in the acceleration time history curves for each head impact analysis that was in any of those list files and calculate the head entry. So if we just go and have a look, we can see that whirring away in the background. And if we go have a look in that folder that we've made with the results in, I can't remember what we called it now. Analysis results. We can see that that's starting to be populated. So a image of the hit curve, CSV file of the hit curve, and a .curve file, which is the format for reading a curve into THIS. One of those is being generated for each of our head impact location. We can see that this list is starting to grow as Reporter is working through each of the head impacts in our list file. Instead of waiting for the template to finish running during this webinar, I've got one that I ran earlier that we can go and look at. So once the THIS has worked through all the head impact analyses in the list file. It will then generate a report which looks something like this. And this is a cover page which really just summarizes the results. So it's calculated the Euro ENCAP head impact score. And it's also got some displays here showing the makeup of where that score has come from. And I'll talk a bit more about this summary table as we go through the template. So this is a cover slide really summarizing the results. The second slide has a bit more information about where that calculated ENCAP score is coming from. So we've got the number of points from orange, yellow and green impacts, and that's that 14.3 score again, which is on the front page as well. We also have the option here to change the bands. So for example, if we have our own internal targets for these bands, we can use this edit settings button here and change these values. We can also save these as a preference so that next time the template is generated, it automatically uses our preferred bands. And if I was to hit OK on that, which I won't do during this webinar, the template would update the bands, but also update all these plots and update the score. The next slide, so after this slide, in fact, I should just touch on this plot on the right and what that is showing us. This is, we've called it a band sensitivity plot, and impacts which are within 50 hit points of changing score are annotated with this crosshair symbol. So you can see a couple of them where my cursor is now. And this is a good way of identifying impact points that could help improve the overall score. So these 2 points here are yellow points, but they've got the green crosshair symbol, meaning that they're 50 hit away from turning from yellow to green. And there'll be more information on plots like this when if you join the HIC area calculator webinar in a few weeks' time. So then moving on to the third page of the template, again, it's just more of a breakdown of the number of points scoring in each band and what percentage of the total number of points that makes up. We also have the option here to set some default red points or default green points for the older regulations. So, for example, let's say I hadn't analysed points on the A pillars maybe. We can use this point here, which is not analysed as an example. So it's in row 8, or row 17, column 8, and I can find that in the table, row 17, column 8, and I can input whether that's red or green. We'll say red, and then the template should go then. It's added a red point in that grid location and recalculated the score on the front of my template. On this page, I could input data from physical testing. So on the left, I can input test data for any head impact locations that have been physically tested. For example, by pressing set test points here, let's say I've tested the head impact point on the grid point 0, 0, and maybe that had a HIC of 800. I'll just do one example for now, and if I press OK, again, the score will be recalculated, taking into account now the correction factor from the verification data that I've just input. And that's included in this table here, and a breakdown of how the score is calculated, which is just as per the regulation, is shown at the bottom of the table as well. And it's a similar behavior for any blue zones, so I could input on this side of the template some blue zones and the head injuries from physical testing for those points. Again, my score would be updated on the cover page and included in this summary table. Now, the rest of the template just contains the HIT codes for each head impact analysis, which was post-processed. And that's the entirety of the ENCAP head impact template. It's very useful in automatically extracting head impact results and calculating the ENCAP score and presenting it in an easy to understand format. The Next template I wanted to show in this webinar, it's fairly similar, but it's the GTR head impact template. It works actually almost exactly in the same way as the ENCAP template. So we would have to select input list files containing the head impact points which we want to post-process, but the final report looks a bit different. And I won't go through how to create that again because it's very similar to the ENCAP one, but we can just look at what the final report would look like. So again, the head injury has been extracted for each head impact analysis, but now the results have been checked against the GTR criteria. So we have the combined area calculation and the child area calculation. So this is to check that the HIC isn't exceeding 1,000 over 1/2 of the child test zone, and that it's not exceeding 1,000 over 2/3 of the combined adult and child test zones. The reason that there's 2 rows for each of those criteria is kind of broken down on the next slide. So the points percentage that's given, this 92.3, all that's done there is that the number of points which are yellow is divided by the total number of points. So it's the percentage of points analysed which are yellow. The area percentage calculation is a bit more fancy in that a 10 by 10 millimeter grid is created, and it looks like a contour plot because we're quite zoomed out here, but if we zoomed in, we see we've got a grid which is now 10 by 10 millimeters instead of the 100 by 100 millimeter grid that we've analysed. And the HIC values for points on this refined grid are interpolated from the head impact points that we have analysed. And then the area, percentage area, then is calculated by the percentage of those points on the 10 by 10 grid divided by the total number of points on that 10 by 10 grid. And there'll be more detail on this combined HIC area plot in the webinar on the HIC area calculator tool. These plots here are generated from that tool and just presented in this template. Again, we can edit the bands for the low and high HIC values if we have our own internal targets. And there's some other settings related to this plot which we can also edit on the template, which will be covered in more detail in the next webinar. There's some more plots which again we'll go through in a lot of detail in the HIC area calculator webinar, but they are also shown on the template. And just like the ENCAP template, we then have the HIC code for each of our head impact locations. So those were the only 2 head impact templates I wanted to show today, but as I say, we also have the China ENCAP, a template for the China ENCAP regulation. But I think now we'll move on and have a look at some of the templates that we provide for post-processing leg impact analyses. So again, I'll open up a new session of Reporter, and we can choose a leg impact analysis template now as well. I'll just go to the area where my results are. I've also got some leg analysis results. I don't have a full sweep, but I've got some results for lower leg analysis, and I've got some results for upper leg analyses. Back to this window again, we go to automotive, pedestrian, and then leg form, and we're going to choose the Euro ENCAP 2023 leg impact template. And just like the head impact templates, we need to feed Reporter a list file. So we press OK and go to where our results are, leg analysis. These list files are already prepared. I think we would first ask for the lower leg impact list file, which already contains the necessary information we need for the post-processing, and then we need the upper leg impact list file. Just before we hit OK and the template starts, I'll show you what those list files look like. They're very similar to the head impact files. So at the bottom here, we've got the path to the input keywords, the name of the point, and the X, Y, and Z coordinate. And this information at the top is what reporter needs. So we've got the cross-section IDs from where the femur and tibia bending moments can be extracted from, and also the spring ID of the spring for the MCL elongation criteria. We go back to reporter now. We also then need to create a directory to write the output to. Go back leg results. And just like the head impact template, reporter will launch THIS and start post-processing our runs. Because we only have a few, it will probably work through them quite quickly, and we can see the end result. So we can see now that the templates is post-processing one of our L1 analyses, so the lower leg at position 1, and it's extracting the femur bending moments. It's extracting the MCL displacements. It's actually extracting the tibia bending moments as well. And all these graphs that we're seeing flash up on the screen now are being written to that directory which we specified. And again, we get an image, we get a CSV file, and we get a .cur file. We can see that folder is being populated pretty quickly now. If we go back to reporter, I was hoping the timing of this would work out so that we could have a look at the final template. I think it's just working its way through the last of the analysis that we have. You can see that it creates a graph for each of the upper, mid, and lower bending moments, and then calculates the score based on the worst of those. And it also does the upper leg post-processing, because I provided the upper leg results as well. So the sum of forces for that criteria. It should be done any second now. If not, I'll open the finished result. At the end, when it's finished generating the report, it will ask you if you want to save it out in any of these formats. I'll say no as now for now, because we can just review it directly in Reporter. And this is what the end result would look like. I've only had L0, L1, and 2, and the equivalent on the other side. And they're not set up in quite the right locations. But if you had all the impacts, you would see them all in this plot across the front of the vehicle. The way it calculates the score is it just takes the score from the impacts which you've analysed and divides that by the total number of impacts. So that's assuming that 1 point is available for each impact. So it would have summed the score for each of the 5 impacts that were in my list file and divided that by 5, and then multiplied that by 4.5 to get the score normalized out of 4.5. In a very similar way, it calculates the femur bending moment score out of 4.5 and the knee and tibia score out of 9. And then this total leg form impact score that it's displaying is just the sum of the upper leg form and the A-ply scores. The rest of the pages just contains a breakdown of the results for each impact location. So we have the upper leg form results for each location, which is just this sum of forces. We flick by these. We also get the lower leg form results, and it shows each of the curves that it looked at, so the upper bending moment, center bending moment, lower bending moment, and then the score is the worst score of those three. And yeah, if we kept looking through, we'd see that the template has extracted the curves to compare against all the relevant criteria. So we also have the MCL displacement curves, the femur bending moments, and the upper and the tibia bending moments, and that's then what contributes to the score on the cover slide. There's also a template for post-processing legal leg impact results, and also you would have seen when we opened Reporter, there were several other ENCAP regulations that we could have chosen. KNCAP, JNCAP, CNCAP, for example. The final thing to say, I think, on the templates is that one thing that's really useful is that you can set the templates to automatically run after your analysis has been completed using the Oasys shell. And that means you wouldn't have to go through the interactive bit of feeding in the list files at the start of the analysis. So you can submit your analysis overnight or over the weekend. And when you come back in the morning, the report would have already been generated with your preferred settings, which is quite powerful. So I think that's actually it from me on the Pedestrian Reporter templates. Hopefully that's given a flavour of the power of what these templates can do in terms of reducing the time spent post-processing and quickly calculating performance against various different regulations. We're always looking to add the latest regulations to our library and improve on the templates in any way we can. So if you're using the templates and you have any feedback, please don't hesitate to get in touch. As I've mentioned throughout, all our webinars are on the Oasys website and on our YouTube channel. Sorry. The Oasys team also send a monthly newsletter, which you can sign up to get updates about upcoming webinars. And we also have training courses, which you can register for on our website. And yeah, as I said, please don't hesitate to get in touch if you have any questions or comments on not just this webinar, but on any of the software or LS-DYNA. You can contact your local Oasys distributor. So I think that's it from me. I'll just check the questions to see if we have any questions in the chat. It looks like there aren't any questions. So thank you all very much for joining, and I hope you found that useful. And hopefully I'll see you at my next webinar on the HIC area calculator and pedestrian rim builder tools.